Hello and welcome to everyone on another live stream, and today we are going to learn about integration by substitution by using trigonometric identities. And this is my lecture 4 on this topic, and I hope that you have watched all my previous 3 lectures related to this topic. So if you are new to my channel and you are watching this live stream for the first time, then I would encourage you to please go through the playlist of a complete course to introduction, and then you will have a basic understanding of how we can solve the integral, and then you can watch this video and you can learn something more about it. So without wasting any single moment, let's begin with today's lecture. So now the idea is why we are using integration by substitution. Like I said in my previous videos, that the idea of using the substitution method in integration is basically to make sure that your integral is becoming easy and easy. And the other thing is that in integration we really can't do the integration when we have a function like sine squared theta, cos squared theta and tan squared theta. The integration is possible only for those trigonometric function when we have the power of trigonometric function is basically 1. So in today's lecture what we are going to do, that we are going to use the integration by substitution by using the trigonometric identities. So I am going to begin with the first question, which says integration dx over x square minus a square. Okay, and this should be equals to ln of x plus x square minus a square root. So this is the basically proof that we want to find it out, and we want to make sure that once you evaluate this integral by using the substitution method, it's coming equals to this. And why we are using this c basically represent the integration of constant over here. Okay, so I'm going to begin with this question, and over here we are going to do the substitution. So the substitution we are going to use that let x is equals to a secant theta, and let me explain and let me give you a quick explanation over here that why we can use this integration and how we will be able to know that we need to do only this particular type of integration. We need to take this particular type of integration. Whenever you have an integral, alright, whenever you have an integral and an integral square root of x square minus a square, right, x square should be your first value and a square should be your second value. In these type of integral, when you are having square root of x square minus x square, you are always going to plug in x is equals to a secant theta. Alright, since this is the second lecture on this topic of integration by substitution, and in my previous lecture I have also explained that whenever you are going to take any substitution, what you have to do is that you got to take the derivative of it. So I am going to take the derivative of x with respect to theta over here. So dx over d theta would be equals to a, and derivative of secant is basically secant theta and tan theta. Okay, so now from here we want to separate the dx and d theta. So dx will be equals to a secant theta tan theta, and d theta will be over here. So now what we are going to do now, we are going to plug in these values over here. So let me see if I'm having the space below. Yeah, I still have a margin to write it down. Now integration, instead of writing this dx, what I am going to do, I will be plugging this value. So it would be a secant theta tan theta d theta over square root. Now instead of writing x square, what I am going to do, I will be putting the value of x, which is a secant theta. So x is a secant theta square, then we have a square. All right, okay, so now I can draw a line. I don't know what happened to the internet connection. Let me see the chat if somewhere there was some problem with the internet. And did you guys miss anything? Please let me know in comment if you did miss anything. So before erasing, I could explain this whole thing again. Okay. So in case if you have missed anything, I am going to repeat it. So in this integral, what we are going to do that while evaluating, this should be equals to this thing. So I have taken the substitution x is equals to a secant theta, and whenever you are taking the substitution, you got to take the derivative of that. All right. So once you have taken the derivative, you have to make sure that x and theta are on the separate side. So now you are going to plug in this value x is equals to a secant theta into this integral, and also you are going to replace dx to with this whole thing over here. Okay, are you clear? Are you clear till here? Please let me know in comment, and let me see if you guys miss anything. Thank you all of you for being here with me in this live stream. So I can see your hello and hi to all of you who are writing that. Okay, so please let me know in comments if during this live stream I think that there was some problem with the internet connection, and I don't know, but let me know if you guys missed any of the explanation. Okay, so this is what basically happened, that now by using this identity secant square theta minus tan square theta equals to 1, I have come to this place and I have got this form now here. Now what I am going to do now, I am erasing this part. Okay, I am erasing this part, and I will try not to erase the first step because we're gonna need it in the later. Okay, so it was integral secant theta tan theta d theta. The denominator would be as it is, secant theta tan theta d theta over, instead of writing this square root, now what you have to square root, instead of writing secant square theta minus 1, we got the value of it, which is tan square theta. So this is what you are going to put, tan square theta. All right, now we can cancel this square with this square root. So we have got secant theta tan theta over tan theta integration, and then we have d theta over here. Now we can cancel this tan theta with this tan theta, and we have simply got, we can erase this part. I am going to be on this side, so that if somewhere someone wanted to take the screenshot or someone wanted to note it down, you can please note it down. Then I am going to erase that part, and what we have got, we have only got integration of secant theta d theta now. Integration of secant theta d theta. So now since derivation and integration is basically the antiderivative, or often we say that integration is opposite of derivation. So what would be the integral of secant theta? It would be equals to ln of secant theta plus tan theta, and please do not forget to put the value c, which is the constant of integration. So ln of secant theta plus tan theta plus c. Now what we have to do, while when you are evaluating this integral, this should be equals to this thing. All right, so what we have to do now, by taking this substitution, we are going to plug in these value over here. So what you are getting, if I move this a to the other side, I can write this as x over a equals to secant theta. Okay, a is multiplying with secant theta. Once you move to the other side, it would divide, and it would be x over a equals to secant theta. So I am going to plug in the value of x over a over here instead of writing the secant theta. Remember, whatever substitution you are taking in your integral, you have to replace it back. So we converted the whole question from x to theta, and now we are moving back from theta to x. So this would be ln of, instead of writing secant theta, this would be x over a plus tan theta. Now how we are going to find out the value of tan theta over here? It's very easy, by using the trigonometric identities again. Once I was solving this question earlier, over here I wrote a trigonometric identity which says secant square theta minus tan square theta is equals to 1. Do you remember that? Secant square theta minus tan square theta equals to 1. Now we know that it's a basic rules of math. Once you have one value, you can find out the other very easily. Now in this trigonometric identity we do have the value of secant theta, which is x over a. We are going to put it in this identity and we will be getting the value of tan theta very easily. So I am doing all, now we don't need this, so I can do the calculation over here. So it would be, the identity was secant square theta minus tan square theta is equals to 1, right? We wanted to calculate the value of tan theta, so this will go to the other side. Secant square theta, 1 will come over here, and this is tan square theta. Plug in the value, secant theta is x over a, so this would be x square over a square minus 1 equals to tan square theta. Remember, we have to find the value of tan theta, not tan square theta. So I am doing some direct step over here. So once you are taking the LCM, it would be x square minus a square over a square equals to tan square theta. So if we remove this square, it means that we have to take the square root on the other side. Actually we are taking the square root on both sides, and over here square and square root are getting cancelled. So this would be equals to x square minus a square over square. You know, this is a property of square root, that if we have a square root like m over n square root, so it can be written as square root m over square root n. Do you agree with that? We can break down the square root on a whole fraction. So similarly it would become a. Why a? Once you will be breaking the square root on numerator and denominator, a square, and there is square and square root both will cancel with each other. So this is basically the value of tan theta that we have got now. So we are going to plug in this value back, and tan theta is equals to x square minus a square, x square minus a square square root over a plus c. Okay, so now over here we can take the LCM, ln of x plus x square minus a square over a plus c. Okay, now we know that this is basically ln of u over v, So whenever we are having ln of u over v, we can break it down. So this would be equals to ln of u over v is basically equals to ln of u minus ln of v. Okay, so this would be equals to ln of x plus x square minus a square minus ln of a plus c. Since the a is a constant, so ln of natural, once you take the natural log of any constant number, it will give you obviously a constant value, and c is also the integration of constant. So instead of writing that all thing, we can write c. So ln of x plus x square minus a square plus c. So this is basically the answer, and let me see, yeah, this is exactly what we have got over here now. So I am going back. So if somewhere you wanted to note this question down, you can note down very easily, and please let me know in comment if you have any problem related to this question. I will be giving you a quick overview if somewhere someone have joined us, you know, a little late, so that they can know what actually we did in this question. Okay, so the question was basically about integration of dx over x square minus a square. Not to be neglected, we are covering the topic of integration by substitution. I have one video, I have in fact 3 videos on this topic, integration, and this is the second part of integration by substitution using trigonometric identities. I have one video earlier in which I have explained the basic concept of how to do integration by substitution. So if somewhere you are joining this live stream little late, so I am explaining this question that we have to evaluate this integral so that we are getting this form. So in order to do that, we have used the substitution using trigonometric identities, which says that whenever you have square root of x square minus x square, you got to take x equals to a secant theta, right? So this is a basic principle that whatever substitution you are taking, you got to take the derivative of it as and plug in the value back, and by using the manipulation we have come to the conclusion that this is exactly that what we are looking for. All right, so whoever joined us late, yeah, hello, how are you? Yeah, I am great, and hope all of you. Thank you for the appreciation, guys. So this is basically my purpose in make sure that when I was young, when I was in my school, I struggled a lot in my mathematics. So this is what my aim was. If somewhere I got masters in mathematics, so this is my responsibility to make sure that the students are getting the right concept. So if you are please new to my channel, then I would really encourage you to see the whole bunch of videos that I have made it for you guys, only for you. So you can check the various playlists that I have created, and you can learn a lot, and I am sure that you will be learning a lot from these videos. So please do share this link with your friends, maybe they are looking for it, since the exams are very near. So you have to make sure that you are not only studying, but you are studying with the proper concept. Okay, so we are going to solve another question. Okay, so now we have integration a square minus x square dx, and this should be equals to a square over 2 sine inverse x over a plus x over 2 and a square minus x square using the trigonometric identities. And we have that once you are evaluating this integral, this should be equals to this right hand side. Now if you look at this integral, or if you look at this question at first, you might be a little surprised that, oh my god, we have never solved these type of questions, or this question is so weird that how we could get a very big thing out of this small integral. Do not be scared of whatever question you are going to have in your math exam at all. What you need to do is basically that keep going on with the basic concept that you have and go with the flow. Try to remember what was the substitution. Okay, the first step is to make sure that you are taking the right substitution. Once you are taking the right substitution, obviously you are going to go rightly in while you are solving this question. Okay, so the solution over here, whenever we have square root of a square minus x square, we always need to take x is equals to a sine theta. This is the basically substitution that we have over here. Now the idea is to make sure that you are taking the right substitution. Now the second step, whenever you have taken the right substitution, you got to take the derivative of it. So I am taking the derivative of x with respect to theta, and this would be dx over d theta equals to a. Derivation of sine is basically cos theta. All right, now we have to keep x and theta as a separate entities. So I am shifting d theta to the other side, and it would be equals to a cos theta d theta. That's it. In mathematics you are always getting marks on your steps. The first step is to take the right substitution, then you have to take the derivative, and then you have to plug in these value back in your initial integral. So integral a square, this is square root a square minus x. Now you will not be writing x. So instead of writing x, we will be writing a sine theta. Since there is a square, so it means that we will be having square on both these terms, on square a and on sine as well. So this would become a square sine square theta, right? And make sure that you are plugging the value of dx as well. Okay, now what is dx? Dx is equals to a cos theta d theta. So over here a cos theta d theta. So we have transformed the whole question from x to theta. All right, we have transformed the whole question from x to theta, and this is what we are going to now solve it. All right, now you can take a square common from here. Now I am going to do a direct step, and I will be explaining it to you, alright, like I did in my previous question as well. So since a square is over here and a square is over here, so you can take a square common, so it would be a square into 1 minus sine square theta. So we wanted to write this a basically out of this square root, out of this square root. So once you are taking a square out of this square root, it would become a, and the reason of becoming a is that basically square and square root will cancel. So I can write a, and in dot we have a over here as well, and once a is coming out from here and you have another a over here, so this a and that a, it would become a square basically. Alright, I never wanted to do these direct step, but the reason I am doing this because I wanted to make sure that within a short time we can solve and we can achieve maximum target. So these are very simple and basic steps, although I am explaining it as well. So if somewhere you are confused, you can still let me know in a live chat, or you can, whoever those watching this video later, they can comment it here, and I will try my best to reply to all of you. All right. Okay, so inside of square root we got 1 minus sine square theta. We are using the trigonometric identity again, which says sine square theta plus cos square theta equals to 1. Alright, note it down please. Sine square theta plus cos square theta equals to 1. So we can, alright, let me write it for you. Sine square theta plus cos square theta equals to 1, and now from here I can shift sine square to the other side, so cos square theta will be equal to 1 minus sine square theta. So this is what I am going to plug in. So a square, remember once you put square root, instead of writing 1 minus sine square theta, you will be putting cos square theta. This square will cancel this square root and we will only be getting cos theta. We have cos theta here again, cos theta and d theta, right? So I am going back, alright, so that you could have a full view of this question, and please let me know in comments if somewhere you are struggling. Alright, thank you. Please ask me some relevant question if somewhere you have it, so that we could move on to our target. Okay, so this a square will be out, so cos theta and cos theta would be cos square theta d theta, right? Now again we have some problem here, and the problem is just not like that we have solved a wrong question, but in fact the problem is that it is never possible to solve or to take the direct integration of the trigonometric identities or trigonometric function who have power more than 1, like sine square theta, cos square theta, tan square theta, and up to so on. So what we are going to do here, we will be using the double angle identities formula in order to get the value of cos square theta. So I will not be erasing this first step because we gonna need it in a later part, and yeah, we can erase that all. Okay, please share the link of this live stream to your friends if somewhere they wanted to understand integration and how basically this works. So okay, cos 2 theta is equals to cos square theta minus sine square theta. Alright, now I need cos square theta, so what I am going to do, I will be placing the value of sine square theta over here, which is 1 minus cos square theta. So cos 2 theta would be equals to cos square theta minus 1 minus cos square theta, and cos 2 theta would be equals to cos square theta minus minus plus cos square theta, it would be 2 cos square theta minus 1. Okay, shift this minus 1 to the other side and it would be cos 2 theta plus 1 over 2 is equals to cos square theta. So this is the value of cos square theta that we have got over here, and now I am going to plug in here. So this would be equals to a square and integration 1 plus cos 2 theta over 2 and d theta. Alright, please note this down, and if you have any question you can ask me. Okay, it's going fine. Great. What next? Okay, so which portion should I erase? We don't need this, since this was just a transformation in order to get the value of that, but you do need it. So I'm going back for some seconds, so that if somewhere you wanted to take the screenshot of this whole thing, you can take it down. Okay, now let's erase this portion. Okay, since 2 is constant, in denominator 2 is constant, and we don't really need that, so we can take that out. So a square over 2 integration of 1 plus cos 2 theta and d theta. Okay, so a square over 2, I am writing the bracket, so we have to take the integration separately for both these two terms. So integration of 1 would be theta, plus integration of cos 2 theta would be what? It would be sine 2 theta, and once you are taking the derivative of the angle, which is 2 theta, it would be 2. All right, so it would be, we will divide it by 2 plus c. Remember, the derivation of cos 2 theta is sine 2 theta, and you have to take the derivation of the angle as well, and it would be 2. So once you are taking the derivation of cos 2 theta, it would be 2 cos 2 theta, but in integration the cos 2 theta would be equals to sine 2 theta, and the derivation of this angle would be 2, so you are going to divide it by 2. So I think I just said in derivation cos 2 theta is 2 sine 2 theta. No, it is minus 2 sine 2 theta, right? Okay, now what we are going to do, a square over 2, so this theta would be equals to what? Okay, so from here we can get that x over a equals to sine theta, sine will come to the other side, sine inverse x over a equals to theta. So instead of writing theta, I can write sine inverse x over a plus, okay, we have 1 over 2 over here. Now sine 2 theta is basically equals to 2 sine theta cos theta plus c, right? So we can cancel this 2 with that 2, okay, and we can simplify it a little more. Okay, so this is a square over 2 sine inverse x over a. I am multiplying the outer part, a square over 2 a square over 2 sine inverse x over a plus, again this a square over 2 will multiply with this whole thing, a square over 2 dot, then we have sine theta cos theta, sine theta cos theta plus c. Okay, so now if you compare these two results, the one that we have to prove and the one that we are doing, you will be seeing that we have got the first form, which is a square over 2 sine inverse x over a. So but still our question is not completed yet, so why I have put this bracket? We don't need it really. Okay, now okay, so this would be a square over 2 sine inverse x over a plus a square over 2 dot sine theta. What's the value of sine theta? You already know that sine theta is equals to x over a. So x over a dot, what's the value of cos theta? What's the value of cos theta? Like I have found the value in the previous question where we were having, I think, the secant square theta, and we get the value of tan square theta. So by using the trigonometric identity, again sine square theta plus cos square theta equals to 1, we will be using sine square theta plus cos square theta equals to 1, where we have the value of sine theta, which is x over a. We will put this value of sine theta equals to x over a into the trigonometric identity, which is x sine square theta plus cos square theta equals to 1, and once we evaluate it for cos theta, we will be getting the result. Okay, and how we are going to do that? Okay, let me do it for you. Sine square theta plus cos square theta equals to 1. So cos theta would be equals to 1 minus sine square theta and then square root. Okay, you have the value of sine theta which is x over a. So 1 minus x square over a square. Why square? Because we have square over here. Okay, so this is square root. So once you evaluate it, it would be a square minus x square over a. So this is basically the value of cos theta. Okay, this result is basically the value of cos theta. Okay, and we will be putting it here. Cos sorry, not cos theta, we have to put its value. So it's a square minus x square over a plus c. Okay, right. So I can erase this part now. Okay, so a times a would be a square and we have a square over here, so this would be cancelled with that. So this is a square over 2 sin inverse x over a plus x over 2 a square minus x square plus c. This is the concept of integration. Now you see, this is exactly that we were looking for. So please note it down, and if somewhere you have any question you can ask me. Okay, hello, hi to every one of you who is saying, and walaikum assalam, I'm great and hope so are you guys. Okay, I'm going back to see how it's working. In a while you can note this down. Please take a screenshot if somewhere it is necessary for you to take it. Okay, now we are solving another question. With the same method, which is integration by substitution, and let's see how we are going to do it. Remember, in the first question we have taken the substitution as x is equal to secant theta, and in the second question we have taken the substitution x is equal to a sin theta. And the reason I am solving different questions with different substitution, so that you could have a better understanding of how to do and how to solve these questions. Okay, another question which says integral of 1 over a square plus x square square root and dx. Okay, we just need to evaluate this integral. Okay, so whenever we are having a square plus x square under within the square root, then we have to take down the substitution as this. So x would be equals to a tan theta. Remember, you just need to take the right substitution. So if somewhere you have started your question with the wrong substitution, so do not expect that it's going to lead you to the right answer. Wrong substitution will always lead you to the wrong result. Okay, so again take the derivative of this dx over d theta equals to a, and derivation of tan is secant square theta. Alright, d theta will move to the other side and it would become dx equals to a secant square theta and d theta, right? So now we can plug in these value. In denominator we have dx, and the value of dx is a secant square theta d theta over, under the square root we have a square plus, instead of writing x square, it is a tan theta, and this would become a square tan square theta, a square tan square theta, right? So I can draw a line in order to separate it. So integration on numerator we have a secant square theta d theta over, again a square plus you can take a square common, so it would be a square into 1 plus tan square theta. Once you are taking a square out of the square root, it would become a. Okay, it would become a. So we can write a into 1 plus tan square theta. Alright, secant square theta minus tan square theta is equals to 1. Okay, so a we can cancel this a, and this would be secant square theta d theta. Oh yes, now secant square theta minus tan square theta is equals to 1, right? So take minus tan square theta to the other side and secant square theta will be equals to 1 plus tan square theta. So this would be square root of secant square theta. Now this square will cancel with that square root and this would become secant theta. So integration of secant square theta over secant theta and d theta, right? Okay, so one secant theta will cancel with this and we have got secant theta. If you have any confusion till here, please let me know and ask me so that I could make you clear it. Okay, so that's fine. Now what is the integration of secant theta? Integration of secant theta is basically ln of secant theta plus tan theta. This is equals to ln of secant theta plus tan theta and plus c, right? Okay, so over here we have secant theta and tan theta. We have to get their value. So tan theta is equals to x over a ln of, we have the value of tan theta which is x over a plus c, but we do not have the value of secant theta, right? So we are going to find the value of secant theta from this result, okay. So write down tan theta is equals to x over a, right? Write the identity which says secant square theta minus tan square theta equals to 1 and secant square theta would be equals to 1 plus tan square theta, right? You have the value of tan, put it here, and secant theta would be equal to 1 plus x square over a square, and then we will be having a square root here because we want secant theta, not secant square theta. Okay, so take the LCM here and secant theta would be equal to a square plus x square. Separate the square root on numerator and denominator, so you will be getting this result. Now put this value back, a square plus x square square root over a. Okay, this was the value of secant theta that we have got, and I am putting these value back into my original step from where I found the value. Okay, now if you have any question, I am going back little so that you could note it down and take a screenshot whatever you want for this whole thing. So if you have any question, please let me know in comment so that I could answer them. Okay, so now I am going to erase this portion since we don't need it. So this would be equals to ln of a square plus x square plus x over a. I have taken the LCM over here, and ln of u over v is basically equal to ln of u minus ln of v. Ln u over v is equals to ln of u minus ln of v and plus c. So this whole thing is a constant, so we can write ln of a square plus x square plus x plus c as an answer. So this is what our final result for this integral is. Please note it down and let me know in chat box if somewhere you have any question. Okay, so let's see how stream is working. Yeah, it's perfectly working fine. Okay, now let's solve another question. Okay, the next question is integration ax over a square minus x4 dx. So this is the next question that we have got. All right, now in this question we have to make a little form over here before taking any substitution. So this would be ax over a square, x4 can be written as x square and then square root dx. Right, now okay, so ax over a square minus x square and square root. Remember, this is a square minus this whole thing is basically your x. This whole thing is basically your x, and then there is square on the outside. But over here, x is basically x square. So while taking the substitution, you have to be very careful in this question, right? So x square is basically equals to a. What actually our a is? Over here, if we would be having 1, then this would be 1. If over here we would be having 3, so this would be 3 as well. So x square is equals to a sine theta here again. So you have to take the derivation. So 2x is equals, sorry, so 2x and then dx over d theta would be equals to a sine, derivation of sine is basically cos theta. Okay, shift d theta to the other side and it would become a cos theta d theta, right? So I am going to take 2 down to the other side, and x dx will be equals to a over 2 cos theta and d theta. Now we are going to plug in these value back. So integration a, instead of writing x dx, I will be writing a cos theta d theta, and there was 2, so that 2 I can write it down in denominator, square root a square minus, so what is x square? X square is a sine theta. So once you are opening this square, it will become a square sine square theta. So a square sine square theta as well. Okay, now again this a times a would be a square. You can take a square over 2 outside the integral since they are constant, cos theta d theta. Over here we have a square, over here we have a square. So once you are taking this a square outside of square root, it would become only a, and 1 minus sine square theta would be cos square theta, and cos square theta square root would be equals to cos theta. Now the reason I am solving these little steps directly, because we have solved them 2 to 3 times in the previous question. Cos theta cancel, a and a cancel, so we got a over 2 integration of only 1 d theta, right? Okay, so a over 2 integration of 1 would be equals to theta and then plus c. So a over 2, and what would be the value of theta? So a will go down, so x square over a equals to sine theta. Alright, we can do a little over here, x square over a equals to sine theta, and this would be sine inverse x over a equals to theta. So this is basically the value of theta which we are going to put it into above result. So theta is basically sine inverse x over a plus c. Now please do not cancel this a with that a, because that a is in the angle of sine inverse, so you can't really cancel that out. So this is the answer of this integral. Alright, if you have any question you can ask me. I'm going back so that if somewhere someone wanted to take a screenshot or note it down, you can do that very easily. Okay, so that's it for today. Thank you for all of you for being with me in this live stream. I hope that my videos are really helping you out. So if you are new to my channel, then please do consider subscribing and share this channel link to your fellows and friends as well, so that they could learn. Thank you.